Chapter 2, Science, Matter, Energy, and Systems. This case study at the beginning of the chapter is a great example of a controlled experiment in environmental science. The Hubbard Brook Forest, located in New Hampshire. They had an independent variable, right, clear cutting. So they were looking at what impact does clear cutting have on the dependent variable of water flow and the nutrient content, so what basically dissolved into the water. And so they did this great controlled experiment. They gathered a lot of data over 3 years, and they found, no surprise, that clear cutting of forests increases the flow of water, so less water is being absorbed into the ground, and also increases the nutrients that are dissolved in that water. So there's less nutrient holding capability in the soil. So great example of science at work in environmental science. Usually it's much more complicated to do a controlled experiment in environmental science because we're dealing with ecosystems. So the first part of the book should hopefully be pretty straightforward, okay? If you are unfamiliar with the scientific method, which I know you're not, but if you are, please see me or just read this section closely, but make sure you are comfortable with the steps. You will need to be able to design a controlled experiment to test hypotheses. This is something that has shown up as a free response question on the AP exam. So we'll look at some examples, and we'll be doing this as well this year. But this is review. You've been talking about scientific method for quite some time. Page 34 kind of deals with, the process of science and what it means, but I think it's really important to bring up this idea of peer review. So look for this when you're finding current event articles. Look for good journal articles that involve peer review. In this day and age with the accessibility of information on the internet, it's really easy to fall for fake news and these clickbait headlines. So read beyond that. Make sure the news that you're reading is good scientific studies. This little science focus box here on page 35 is a really interesting look at Easter Island, which maybe you've heard of before, sometimes called Rapa Nui, which is the other name for it. And you might recognize these little head statues here. But they're kind of the working hypothesis for a very long time is that the people who lived there kind of had unsustainable resource use, but then just in the early 2000s, they came up with this idea of maybe it was actually invasive rats, so based on new data that's been found. And as they continue to study Easter Island, they might come up with more hypotheses. So again, science, it's not set in stone. When we have a lot of well-tested hypotheses or a group that all continuously work together, that's when we get into theories. Theory of gravity, theory of evolution, the Big Bang theory, cell theory. But a lot of what we work with are hypotheses. And those can change as new information is found. And again, this goes into that. So the idea of it can be tentative, things change, etc. This science focus dealing with statistics and probability, we don't need to do a lot of that because we don't have calculators for the exam, so you won't have to worry about doing any statistical calculations like you might have to in AP Bio. But this is why large sample sizes are better because it reduces the possibility of errors occurring. Then, what is matter? Chapter 2, Section 2. A lot of this is review of things you've talked about in middle school and what you're doing in chemistry if you're taking chemistry right now. So review all of this: neutrons, protons, electrons, isotopes, molecules, ions, etc. On page 40, however, there are two charts, two tables. Table 2.2 and table 2.3 have a list of, here we have different symbols and ions that you need to know. And then table 2.3, a whole bunch of different compounds that you need to be familiar with. Sorry, it's not really focusing. My phone's very old. So know those. Also a little introduction to the pH scale, which you talked about in biology and chemistry if you've taken that. So just remember, strong acids have more hydrogen ions, strong bases have more hydroxide ions, neutral is 7, So that will come up again later on. Again, organic versus inorganic, etc. And then we get into this idea of high quality and low quality matter, cells, genes, chromosomes, etc. Review of biology. So that's great. Then we get into section 3. A couple of things to remember. So the law of conservation of matter, how that relates to environmental science. Nice little connections box here on page 43. Right? If you burn trash, it might be like, oh, most of it went away, or you burn wood or anything, but you are still left with ash, and then a lot of that matter gets converted into gases in the atmosphere. Oftentimes that's pollution. Also on page 43, we have comparison of nuclear fission, which is when the atoms, or the nucleus of atoms are splitting. That's what happens in a nuclear reactor, versus nuclear fusion, when two nuclei actually come together. That happens on the sun. Section 4, dealing with a little bit about energy. So we get introduced to the idea of kinetic versus potential energy. They give you a lot of different examples of kinetic energy. The energy of, right, this is the energy of motion. So it includes the movement of electrons. Oh, we got a little fruit fly hanging out in the Post-it note. Hello, fruit fly. So electricity, heat, radiation, which figure 211 shows you. That includes light energy. And then there's also potential energy, so stored energy, the energy behind a dam, all of that water, that's potential energy, which then becomes kinetic energy as the water moves through the dam due to gravity, and then that gets converted into mechanical energy, moving a turbine, and then that is connected to a generator, which turns it into electrical energy. So, bye, little fruit fly. We're going to go on to, so here's our UV light and electromagnetic spectrum and that potential energy of the dam. High quality versus low quality energy. You've kind of dealt with this before in terms of the energy pyramid, which I drew on there. Remember that from biology. So we know that energy doesn't go away. Second law of thermodynamics, which we'll get to on page 47. But when we say like, oh, energy is lost as heat, that heat energy is low quality. It's not really useful for anything else. So the laws of thermodynamics on page 47. So the first law, energy cannot be created or destroyed. The second law of thermodynamics, as energy changes form, so it goes from potential to kinetic to mechanical to electrical, etc., it becomes less useful. So we end up with more low quality energy. So we have lots of wasted energy due to the second law of thermodynamics. Usually it's heat. Incandescent light bulbs, or those old school light bulbs, if you touch them, they're very, very hot. Or if you think about your car engine, those car engines generate a lot of heat. That's all wasted energy. So one of the things we can do to reduce our energy use is to increase energy efficiency. Section 5 of Chapter 2 deals with systems and feedback loops. So we have right here a nice example of what systems are, inputs and outputs, etc. But two terms, positive feedback loop and then negative feedback loop. Don't fall into the trap of thinking positive feedback loops are good, because often they're not. Positive feedback loops, and they give you a nice example with the Hubbard Brook Forest here, is when the system continues to change in the same direction. Another example is the melting of polar ice. As ice melts, we get more ocean water, which is darker in color, which absorbs more of that light and therefore more heat energy. So you get more melting of ice, more darker ocean water, less of that reflective ice, etc., etc. So that keeps that system going. Another example is when permafrost thaws or melts, it releases methane, which is a very powerful greenhouse gas, which increases temperatures, which causes more melting of permafrost or thawing of permafrost, which means you get more methane, etc. So those are positive feedback loops. Negative feedback loops, which are discussed on the next page, focused on these in biology in terms of maintaining homeostasis. They're more corrective, right? They cause the system to reset or change back in the opposite direction. Another good example that we'll look at in our next unit are predator-prey relationships. So as the number of predators increases, the number of prey goes down, which then causes the number of predators to go down, which causes the number of prey to go back up, etc. So it kind of gets that nice balance. And then the last thing to bring up in chapter 2 on page 51, this idea of synergy or synergistic effects. This will come up throughout the year. And this is when two or more processes interact, and then their effect together is greater than individually. This makes studying ecosystems really tricky because it's very, very difficult to isolate just one aspect of that system. So you'll see that word again, synergy or synergistic. So here's your introduction to it in chapter 2. And that's kind of your